congruencies. This time we're going to be looking to see if triangle AZF is congruent to BJE. I have the two of them drawn over here. And we're going to do this according to side-side angle. So what I have here is FA congruent to BB. We have AZ congruent to BJ, right? And then we have angle Z congruent to angle J, right? Those are our three givens. And what can we do? What can we do with those pieces? Because we have a side, and an angle. Do we have enough information here? And I asked that question this go around because the truth is we don't have enough information to do anything with this. So I'm going to demonstrate this. I'm going to encourage you to kind of pause this video a couple times and just kind of rewind it and rewatch it just to kind of prove this to yourself. Get a ruler and a compass if you have one, or just make an angle on a sheet of paper and use that as your standard way of measuring the angle. So you can cut out an angle on a piece of paper using a pair of scissors and use that to just draw that angle there. Do the same thing down here in that second piece. Use your ruler and draw out this angle. In this instance, it is 8 inches on my glass board here. This one is also 8 inches. Then this second one here was 8.5 inches. This one is also 8.5 inches. So what we have here are two sides, two pairs of sides that are congruent to each other, and you have angles that are congruent to each other. And we create two triangles that are definitely not congruent to each other. We have one triangle that has a very short side as its pardon me, as its side, and I have a second triangle that has a very long side as its third side. So what does that mean? Well, it means that we can't start with side-side angle. You can also write it backwards, and it really is very interesting to deal with. But I always write it this way because it creates less confusion less disruption, shall we say. Right? But what we can do is we can create two different triangles. This is the only one of these arrangements that we have up here. There's 5 arrangements that work and 1 arrangement that doesn't work. And here's a really good example. Try this out in a couple of different scenarios. There's only one instance where this does actually work. The only time this does work is when it's a right triangle, and then it's actually leg hypotenuse or hypotenuse leg theorem, however you want to write that. That's the only time it does work, is when that angle is a right angle. That's the only time this scenario works. And it has to do with you're saying that Z and J would be the right angles. When those two are right angles, then these two triangles are congruent. Because what you're actually doing is you're creating one triangle that's obtuse and one triangle that's acute. If both triangles are right triangles, you're forcing all the other angles to be the same measurement. They just have to be by sheer fact. And there are ways of proving that one, and I encourage you to go try that proof as well. Do this out with drawing, and this is one of those instances where drawing with this scale to kind of get an idea and a feel for what's occurring is very, very helpful. So do that. Create yourself an angle, an acute angle. Draw the side, draw the second side. Use that same angle, draw that same side, and when you draw that second side, draw it out further out. What you're going to do is you're going to create an acute angle. And then repeat this same process by using Z and J as right angles, meaning the measurement is 90 degrees, so just use the corner of your paper. And when you do that, you're going to create triangles that have to be congruent. That's you demonstrating the leg hypotenuse theorem. Okay? And there are ways of proving the leg hypotenuse theorem using side angle side as well. So I'll let you play around with that and see what you can come up with. Please reach out with questions, comments, and hope you have a good day. Take care.